Good, 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 good. Wait, is it Friday? It is Friday. Good Friday, everyone. Welcome back to the Tech Show. I'm Joel Asante, one of your hosts. Uh, you have Evans here. You have Ezel here in the chat. I want to see W's in the chat, guys. It's a Friday. Can't wait for the weekend. And but yeah, welcome back. As you can tell, we are going live on our official LinkedIn page. I can't tell you how excited I am. I know in the past we've been going live on our personal LinkedIn channels, but also in our YouTube page. But it feels good to go live on our officially on our LinkedIn page. So, welcome, guys. If this is your first time ever watching our show via LinkedIn, the tech show is to help enable folks that are looking to build more things in the cloud, learn a little bit more about cloud concepts, domain, services, technology, or just technology in general. Three of us as of today, but also usually there's a fourth member who cannot make today, are just tech enthusiasts. We love just talking about tech stuff. We love anything that has to do with tech. So with that being said, let's kick off today's episode. Uh, if you were in the previous two episodes, we essentially talked about three-tier web apps, right? The presentation layers, one, and the logic layer, two. We talked about how both are super important when it comes to the three-tier web application deployment or a stack in general. But I think to me, and I think the guys here might disagree, is how important the database layer is. I think when we first got started with this, I specifically was looking forward to this day, right? Database is super important to a three-tier web app. And I'm excited to get into this conversation and get us really deep into the benefits of it, how it fits into the three-tier web app and just in general, best practices, services that would make a play in here, but also architecture that shows you how we can utilize various different techniques to make sure that you are scalable, you're highly performant, but also you are available to the best of your capabilities. So, with that being said, can we get into the conversation, guys? Or am I missing anything?
No, Joel, I think you're right on spot. Like, especially for this episode, we're gonna kind of dive deep a little bit about databases. And it's a hot topic. Like, you just have to, in order to become like a very well versed architect, you have to know like the different layers, right? And that includes the database layer. So it's very significant when you're building out applications, and choosing the right type of databases is something. It's not easy, but once you get the hang of it, you can really expand from that.
Yeah,
Oh
and I
yeah,
like what you said there, is all choosing the right database, right? Because we have a wide range of databases that we can choose from, depending on your applications and what you are using, right? So yeah, I think we can start with that and let our viewers know that
absolutely. So, to Evans's point, choosing the right type of database is always the first thing you want to do, right? It could be a relational database, it could be a key value database, document, in memory, graph, time series, ledger, wide column. It could be a variety of different database types. Choosing database can be as easy, but also can be as complex as of a decision as you can think of it. It could be, hey, I think I just need to have a ERP or a CRM type of database, or I just need something that's more of a real time type of database, or something that could just be a utilized for IoT application, which in this case could be a time series database. It just comes up to you or the type of application that you're building. This is where you decide which type of database you would use. Uh, to that point, guys, what typically is the right approach when it comes to the variety of different use cases? So in this case, we have a common use case of when you would use variety of different databases. What have you guys seen in your day-to-day work would make you choose a specific database?
Yeah, I mean, Joel, like really, when you're trying to choose a database, you got to think about different like criterias, right? So you're thinking about how you want to scale this, how performant you want your application to be, and you got to take into account things of like processing your queries and what type of data types that you're supporting, right? So all those different criteria you have to put in mind. And as you further progress with your applications and you make like your application grows into microservices, you really have to choose the right type of database. And like I said, it takes some skill, but like you mentioned, all the different types of database. Once you know exactly what you need, you can fit that type of um, database engine right in, and you can move forward and beyond.
Yeah,
Absolutely.
and I think for me, yeah, you want to first determine if you want to go with, generally, I know we use relational databases, right? If you want to go with a relational or non-relational database, right? So once you figure that out, you want to look at your specific use case. If, for instance, you want to be able to perform something like, connection, and use graph, and your use case is with the social media, right? You can use, for instance, the graph database. And so it really depends on your use case. You want to sit down, thinking about your use case, and then look at those variety of database. I know you can pull that screen back so that viewer can see, and then of course you can choose the one that works best for you. Yeah. So as you can see, we have the in-memory database, we have the time series, and all of those are goals specifically with some type of applications as well. So
Absolutely. No, that's a great point that you guys bring it up. I think whenever I think of databases, my first thoughts comes back to relational database. That's the most popular type of database. But to me, now that I have utilized a lot of relational databases like MySQL, Postgres, all these ones, I have sort of shifted my mindset to look into more, don't hate me, but NoSQL database. Like for some reason, whenever I build applications nowadays on my personal time, I have now tend to build these applications with NoSQL database. Example, DynamoDB. For some reason, I think it's more of a, I don't have to make it fit into this sort of schema or this format. I can just plug in, plug out, boom. It's key value pair. That's all I have to worry about. I don't necessarily have to worry about the schema anymore. To me, and again, a lot of people might say, well, relational database is where I usually like to start. Yes, I love relational database, but don't get me wrong. I think other types of databases should be considered specifically for the use case of whatever you're doing. So, again, in my use case, I usually use relational database, but I've tend to now more lean to NoSQL database because I think for me it fits more for whatever application I currently I'm building. So, with that being said, then I think the
And Joel,
architecture.
not to cut you off, it's pretty interesting that you mentioned that, because like when you choose these type of databases, you got to see what type of structure you're trying to perform, right? Like you mentioned, you want to be schemaless. So in this case, if you don't want to be super tight on the table structure, the relationships between the different um, tables, and creating the different columns and the primary keys and the foreign keys, and adding those relationships, it's that could be kind of over, right, or overboard for your type of application. But
Yep,
sometimes if you want something to spin up really quickly, something really quick, and you don't want to worry about the schema, then you choose something like a NoSQL type of
SQL
database, right?
database.
And
Yep,
another interesting point is like with relational databases, usually some of the use cases would be like in the finance business, the e-commerce, like those types of like use cases. You want something very performs, or utilizes the ACID principle, right? Atomic, consistency, isolation, durability, and those really make your database more structured for those types of use cases. And you let's say, for example, you have a banking software, right? And you're trying to send like a some sort of payment. So you want that transaction from start to finish to go smoothly, right? And if anything happens along the way, you can kind of roll back without any issues. So that's where something like a relational database might work in this case.
No, that's an interesting point. That's a great point. I have obviously not necessarily built for myself those type of large uh scale or enterprise grade databases. I have obviously architected for it and provide solutions for it. But no, that's a great point for where relational database stand out. And speaking about relational database, can we dive into relational database really quickly on like the different types of engines people usually would see or even want to uh think about? Uh,
Let's do it. Yeah,
is that sweet?
definitely. Yeah.
Awesome. So, what is usually the engine that you guys typically think of when you think of a relational database? Like to me, whenever I first think of like relational database, my first thought is Microsoft SQL or like MS SQL or like
Right.
or Postgres, right? Or MySQL itself specifically. What are usually your first thoughts when you think of, oh, I need to spin up a relational database? Which one would you usually, what type of engine would you usually go with?
I usually think of, for me personally, I usually think of, things of like, MySQL, Postgres, SQL Server, Oracle, like those beasts, like those types of database engines. Usually, typically, you would use, something, a relational database for those types of things. If it's like an enterprise, you might want to use Oracle, right? Because it's something you're dealing with an enterprise software. You want something that's more consistent, more durable, more scalable. You can also use my SQL Server, like Microsoft SQL Server, for that. If it's and I've seen use cases where people just use Postgres and MySQL as their main database. So it just really depends, what's your flavor, what type of SQL you're used to. It doesn't really matter, but something that's familiar with the team that they're used to, it should be fine.
Can a team use two databases for a specific workload?
I mean, they could
I
use
mean,
two, but then it wouldn't make sense, right? Like,
I'm just
uh,
asking because I've seen folks ask those questions and folks actually do that.
right.
You guys usually recommend individuals do that or not?
I don't think I've recommended that. I think you guys mentioned the type of database engine. I think of when we talk about relational, which is MySQL, SQL, Oracle, and all of that. I don't know if Hazel you have worked with a customer that had to recommend that.
I mean, most likely they would use just one because I guess you could say the complexity of learning, even like SQL, the standard language, standard query language, is well known and well defined by everyone, right? But then, for example, for SQL Server, Microsoft SQL Server, it might have like additional learning curve if you want to learn like T SQL because it uses a different type of syntax. So in most cases, enterprise customers, they would stick to one because there's also licensing that gets involved into it, right? Like if you want to use a particular database engine, you don't want to buy multiple licenses from different vendors. So most likely, in most use cases, they would use one, a database engine, and of course, you can add multiple databases, right? You don't have to within that SQL engine or database engine. You can have like multiple databases. But let's say if you want to go above and beyond and you have like microservices, then that particular microservice can have its own custom made like database engine. And then maybe depending on the team that's in that who's leading it, they might go towards a specific database engine. But I
Absolutely.
wouldn't recommend it personally.
That's a great point. Since we're on the topic of relational databases, I want to sort of run through this with you guys when it comes to the benefits of the database layer when it comes to three-tier web apps. Again, in the context of a three-tier web app, when we think about databases, how important is it for that database to be resilient but also highly available? Right. I want us to talk about that and give individuals that are in the call here or that later watches this. Why is it important to when you're architecting your architecture to fit into a three-tier web app scenario? How is it important to make sure that it's very resilient but also it's highly available? And the reason why I asked that question is, and I can pull this architecture up really quick too as well, is you always and always want to make sure that you are deploying into a multi AZ deployment. So multi availability zone deployment to make sure that it's highly available because it comes back to the concept of three nines, right? You want to deploy to two AZs. And the reason why is because that database would be able to automatically handle failovers and ensure that the availability of your database is continuously served to your customer. But also having that multi AZ strategy in place, you're able to synchronize the replication between the primary that you see at the top here, but also to the secondary or the standby database, so that in the case of a failover of an AZ going down and something happening to that database in that one AZ, you're able to synchronously replicate or failover to that secondary or a standby database. But to my point, guys, how important or how is it important to individuals to architect a highly available or resilient database?
Um, yeah, I think is really crucial, right? Your database, which is the third layer, feed data to your application, right? And if there is an issue with your database, your application crashes, right? So we want to make sure that we have a level of resiliency and redundancy to make sure that if something happens, right, we can fail over. Like you mentioned, for me, when I architect with customers and they are using a relational database, for instance, yes, we always want to make sure that we have the primary and the secondary database in two different availability zones, right? Um, and that allows you to be able to um, do replications of your primary data, right? First of all, you want to have two type of replications, right? You want to have the synchronous replications, right, where all of the copy of your primary database, goes to uh, the standby database, right, and that allows you to be able to easily fail over. So definitely crucial. It is important. I don't see how we can architect without really considering that, right?
Yeah,
That's
it's it's kind of like, hey, I'm going to a what is it? How can I was trying to utilize an analogy, but I don't think I have any in top of my head. But it's yeah, to your point, it's super important to have obviously that primary, but also in this case, have a standby for an event that primary goes down. And I was gonna bring something up, but I think Ezra, you wanted to bring a point up. 'Cause I was gonna bring up
Mhm.
read replicas
Yeah.
and how we can bring that to and play here. But
No, I think what even said was straight on, and what you said, Joel, too, because you want the most minimal disruption to your users as possible, right? You don't want them to feel anything. Like when they're using your website or your application, if there's a bug or there's something that God forbid, actually brings down your database engine, you don't want them to be in that situation where like they can't use anything, right? So that's why it's always very important to have disaster recovery in mind, where you have your like what Evans mentioned, you have your primary database and your standby database right there. So if one instance falls or your database engine falls down, then it will be a breeze. They won't feel anything, and that's very important when it comes to architecting
gotcha.
and the yeah.
So to that point, we were essentially are building this architecture, right? Whereas you are, I'm gonna try to make sure that the viewers are able to see it here, but you are building the architecture where you have that primary here, but then you're synchronously replicating that primary to a standby. Then if there's a
Mhm.
failover, it seamlessly or easily fails over to that secondary or that standby
Yeah,
there.
it's just a breeze. They won't feel anything.
You won't feel it.
They will just
Exactly.
keep using their application and nothing will happen. You're gonna like you as the software architect or the developer. You're gonna see that. We're gonna see a lot of logs, error logs, but for them, it's more about convenience, right? You don't want something, and then even if it's like a mission critical application, like you don't want that to. You don't want like your primary database to fall, right? That's just bad.
I could only imagine if someone would architect and say, you know what, screw that. I'm fine if something happens to my mission critical application. No, you
No,
don't want that.
No.
You want to always, you always want to plan for disaster. And I forgot, someone said this. I forgot the exact quote, but it was related to you always want to plan for the worst, right? You always want to plan for the worst. If something was to happen, you want to know that, hey, I am aware that my application or my infrastructure is going to be taken care of because I have planned for this moment. So this is why when you build stuff like this, you always want to have a run book that says, "Hey, if this happens, this is the exact playbook that we're going to take. We're going to take into measure, and also automated processes that would follow to make sure that everything is taken care of due to the mitigation we've had in place." So
Exactly, Joel. And not only that, I mean, it might cost you a little bit more, right? Like just to
to not
have that
have it
stuff.
exactly
Yeah. But then let's say it goes down, like your whole database engine goes down, then
costs you even
what is
more.
exactly, it's just
Yeah.
and
it's not a good image.
I've have customer bring that up, and because of cost, they think that what I've architected was was a lot. But something I've come to learn is that in tech, everything fail all the time, and it's
Right.
always better to have a backup plan, regardless, especially for your database.
Plus
Yeah.
one on that, plus
It's
one.
it's much better to see that thing right now. So when it's gonna affect millions of customers that you might have. To your point, events, you want to architect, and if it's gonna cost you a little bit more to have those things in place, yes, absolutely, do that right now. Then it's gonna then you wait until it actually affects your end user customers, where you're then spending millions of dollars or whatever amount that is to sort of revert back all the issues that happened or took has
Yeah.
taken place. I think
And it
this is
usually
to
costs more when
it
those
costs us
things.
more. Exactly.
Yeah.
Exactly. And this is to like the security conversation we had a few weeks back where you want to take care of the security stuff right now to inevitably affect you later down the line. Where it's like you want to take to account all the checks or what is it called? Like all the cybersecurity things that someone might hack into your system. You want to take care of that right now till it actually happens. Where if someone hacks you, guess what? It's going to cost you more to pay that ransom, whereas you
Mhm.
could have taken care of all those things prior to that actually happening. So it's super important to make sure that those are taken care of before it actually takes place. And I'd say the same thing for database reliability or resilience is to take care of that stuff before something happens. You have that backup in place.
And we
And
have
Uh,
no, I wanted to say we have an interesting question in the chat. Someone is asking, does security and operation management increase for the customer when you have multiple copies? And I think it depends on how you set up your database, right? If you use a managed service like RDS, which I recommend, is takes over a lot of those management function for you, right? So you don't have to worry and do those type of management. So it takes that heavy lift from you, the customer, so you don't have to worry about that. I don't know if you guys have any input as well to that.
no, I agree on that. Even it's like, I had some experience back in the day where like I had to install like SQL Server from scratch onto like an operating system. And
that's
that,
the worst.
that's hell. And what's worse is Oracle when you have to, install that. Like imagine the time it takes for you to install like the whole database engine and go through all that setup process,
Yeah.
Yep.
and then something happens and you have to redo it again. So RDS, like you mentioned, it alleviates all of that for you. So you don't even have to worry about managing your instance. You can focus more on like the business side, where you just want to store those records in. You want to manage those relationships between those tables, design the schema properly. So
The
it's a big thing. Yeah.
the undifferentiated heavy lifting right there.
Yeah.
You want something that's managed and something that obviously takes care of those things for you, like the patch and all that stuff. But I want to sort of point out the security aspect of this question, right? In the cloud specifically, this probably is not different in on-prem environment, but in the cloud specifically, The security of the cloud is the responsibility of the cloud provider. So in this case of AWS, they're responsible for security of the cloud. But security in the cloud has a customer and individual that are architecting this, or in this case, the cloud architects. They are responsible for the security in the cloud. So making sure that you are aware of all the things related to that database when it
Encryption.
comes to security, encryption, all that stuff. You are responsible for that. So you want to encrypt your database. You want to make sure that that's in check. You don't want to leave that up to, hey, it's a managed service, so it's already no. You are responsible for security in the cloud, and this also aligns itself back to databases in the clouds as well, whether it's databases specifically RDS or other types of databases. So I just wanted to point that out.
Yeah.
No, that's straight on.
Very
And then just to add on to that, Joel, is like usually when you create a database engine, you have to put it in a private subnet, right? You don't put it in a public subnet. You want to,
Yeah,
from a security
but
standpoint.
but some people do though, and I know it might be incorrect because some people do just to have access to it because obviously you don't want to do a jump box or go through a bashing host, all that stuff. Why is that important? I want you to speak to that. Why is it important to always have your database? And to that point of, I'm going to bring back up the architecture, right? Why is that database in a private subnet? Why is a private database in the private subnet? And why do we usually architect it this way?
Yeah, I mean, like the database itself, it's your soul, like it's you could say, right? Like if that thing goes down, then it's a wrap. Your whole application is useless. So that you usually want to safeguard it, you want to protect it, and you don't want anyone to access it. So that's why you would usually put in like some sort of security groups in place, so that even the ports that get access to that database is limited by a specific application. Not anyone can come in and do what they want to do. And usually, like when you're building applications, you never want to do any sort of like CRUD operations directly on the database in production. So that's a big no-no. Like if you want your applications should do all of that stuff. But as a database administrator, when you start manipulating the data, like your data within the database on the side, then that's not good because that can even bring in more problems. So it's very important, like even from a security aspect, you want that to be limited.
Yeah, and you
Absolutely.
nailed it there. I think it's security, protection of your database. You don't want to make your database public. That is when I'm architecting. That is mandatory, right? And like you mentioned, in the cloud, you put security group around it and make sure that only the application layer can have access to your database. You make it secure and to avoid any issue.
Gotcha. So, in a sense, if I think of like security measures when it comes to protecting that database layer, would you say is more so of one, the encryption at rest and in transit, but also I'll add to that point fine grained access controls, whether it's utilizing IAM roles or users, whatever it is, that will be key to this too as well. But then, as well, to your point, network isolations. You want to always want to isolate that database into a private subnet and potentially maybe add in like security groups too as well. Not even potential. Yes, add security groups to your databases. Uh, but then my question following that would be, what are the other security measures that are super essential to making sure that we're protecting our sensitive data in that database? To me, when I think of that, I would say maybe doing like database auditing to like track your access and who gets to change data in that database. Uh, but then also maybe having some sort of like what is it like automated security features just like SSL or TLS encryption for a database in transit? What would you say is additional security measures that are essential for protecting sensitive data in databases?
Yeah, I think we kind of mentioned it already. And you just stress on them already. Also on encryption at rest in transit, um, access control, right? Security groups, making it a private subnet. Um, yeah, I don't think as a think about anything else to add there?
Yeah, I think all that we mentioned prior to that is straight on, and maybe in addition would be like creating different users for that database, right? Like you want to have, and this is on the database management side, right? You want to have like users that maybe some analytics users or some a super user just to utilize specific tables, like and that's just to manage those tables. So maybe that could be an extra layer of security where you know you want to fine grain who can access a specific table, a specific database. Um, those are the type of securities measures you can put in place, I think, in addition.
Absolutely. Awesome. Well, I think that's very high level of like resiliency and like highly availability of a database. I think I want to sort of move down to performance and optimization when it comes to databases. That's a huge topic there, right? Why is it important for us to, in this case, use read replicas to offload read operations from our primary database, which in a sense enhances our performance. Uh, to
Ooh.
that point, oh, go ahead.
No, no, you go ahead. I just wanted to say that that's a big one because
Oh yeah,
like
100%.
like when you have imagine you have like a million users using your application, right? And they're all inserting at the same time, inserting records. At the same time, there's some users that are just viewing some specific content. So you want to offload those two things, all right? The inserts and the viewing portion. So it's very important to have some sort of like maybe a database that could read only not just for specific just for doing those OTP jobs, you know.
And I think when we start talking about performance, of course, it is for high use databases, right? It's not for small databases. So yeah, definitely, if you have a big database that a lot of read and write operation are being performed on it, you for performance sake, you want to isolate those. You want to use a read replica, right? Where customers can perform their read operation from your database, and then the write operation can carry on, on the primary database. That really increases the performance and the experience that your customers have when they come on your website.
Yeah. And I'll add to that point. Not only do you want that, what if you have a workload specifically for analytics? So you want to, let's say in a database, you have transactional data coming in and out, and you're like, hey, I want to analyze this. I want to send this to, let's say, data warehouse, whatever it is. You wouldn't want to necessarily utilize that primary database has that instance for your analytics workload. You want to still use that cluster, but you want to use that read replica instance for that analytics workload. In that case, you're not necessarily affecting that primary instances for the read and the writes, but you're only looking at the read replicas for that workload. So for performance purposes, I would say 100%. You always want to utilize read replicas to offload those read operations, in a sense, enhancing that performance. But to that point, I think also another key techniques that I've seen from just my experience with customers is database indexing, right? Properly indexing can speed up tremendously
Right.
how fast your query performance is, enhance reducing that latency you see when it comes to data retrieval. So database indexing is highly important to optimization when it comes to your performance. Then one thing that a lot of people also don't do is connection pooling. So if you ever use RDS proxy,
Hmm.
it's insanely important to utilize it because again, it optimizes that performance. And the reason why it does that is because you're essentially pulling all the connections that you have to that database from individuals and you're efficiently connecting it to that database. And what you end up doing is you're preventing overload from the multiple different connections that are coming into that database. So connection pooling, heavily recommend if anyone is looking to have multiple connections to a database. But
Yeah, and Joel,
is
and
there
you can also talk about like caching, right? Some I've seen some people they add an extra layer of caching when they're doing like those complicated queries. So imagine you're
Yep.
doing like a query, right? You're selecting from multiple tables, doing multiple joins, and it's super complex. You don't want to replicate that query again. So you might want to have some sort of caching mechanism where your application can read from the cache instead of going straight to the database and causing performance jumps. There's
Would
performance
would
spikes.
would this caching be placed in front of the database? And what recommendation would you give? What type of caching service
Yeah.
would you usually
Um,
use?
yeah, it would usually be placed in front of the database, right? And then you could probably use some service like like Redis or Memcache or some sort of like in memory database engine that uses like key value pairs, so that you don't want your database to be bombarded with like queries and all of that. So
Yeah, again, all of that depends on the use cases, right? Those
exactly, yeah.
are specifically things to that play in terms of performance of your database. But of course, when you are evaluating all of those, we want to consider the use case and then choose the right course of action for the customer.
And that goes back to the purpose-built databases, right? So
Yeah,
some database workout, like database engines, they're good for relational workloads, but some are not. So even when it comes to scaling, okay, let's say you want to scale this horizontally. You want to have you have an application that you have a lot of users they're inserting to a database. Maybe a relational database might not be the option that's good for you. You might want to use something like DynamoDB, like a document database, right? A key value database. Maybe that could be a different use case where you want to scale horizontally. So, and there's different technologies that's used behind the scenes, like sharding, where it can manage those types of heavy loads of like inserts operations and OLTP operations. So you really have to like think like what database engine works. What's the best for my use case? So and
Absolutely.
yeah.
Awesome. Well, I think we've covered a lot in that sense because I think we've been going back and forth between data recovery a bit, but also security a bit here too as well. But operationally, how to operate a database.
I think
I
Joel, you
think
missed something, and
yes,
this is
I want
something
to. I
very
was going to
important.
say that
Database
is true.
backups, right? We forgot
Exactly.
about backups, man.
Automated backups. We don't want to just do backups. We want to do automated backups.
Yeah.
But yeah, let's deep dive into that. So when it comes to automated backups, or just backup and recovery in general, how important is it for individuals to automate their databases? And how important is it contributing to when it comes to their data recovery and their disaster recovery planning, right? How important is it for individuals to do automated backups? Because I think a lot of times people think, well, nothing's going to happen. Again, it comes back to the illusion of, oh, it's fine. As long as nothing really happens in the world, everything's going to be fine. Again, you want to plan for disaster. Can we speak to how important is it for individuals to back up their database, but also maybe implement point in time recovery too as well, right? How is it important for us to restore our database in a specific point in time and recover from those point in time for, let's say, if there's a need for us to recover our application when it comes to data corruption. Can we speak to that a little bit more?
yeah,
Why
sure.
it's super important for us to do that?
Yeah, I think you don't want to leave your database or your system up to chances, right? And like I mentioned earlier, things fail all the time. You always need to have a backup plan, right? I'd rather have a backup plan and not have to use it than not having one and then something happen and So and then you just don't want to have a backup, right? When we were answering the question that one of the viewer asked earlier, we talked about the managed service, right? RDS allows you to handle those backup, right, automatically, which takes off the heavy lifting that we mentioned. So that's one of the key advantages of RDS or managed service from AWS as well. So the importance of using automated backups, You don't have to think about it. All you do is check the period, how periodic you want it to go, and it perform that backup for you. And then when you also need to do your point in time recovery, yeah, you can easily perform those. So yeah, I will
Absolutely.
stress out that this is really, really, really crucial, really important.
Absolutely.
Absolutely. I think that's a great point. Even it's like your use cases varies, right? Some use case they want a specific type of RPO, RTO, um, like criteria, right? So depending on your use case, then you wanna like manage that. And I think having periodic backups is very important. If it's hourly, daily, monthly, you just have to have some sort of backup just for those bad times.
Absolutely. I think we missed one other point, and thank you for giving the viewers some insights to why automated backup is super important. But I think we missed one point too as well. Uh, when it comes to databases, a lot of times we end up specifying obviously our database engine. We specify obviously the sort of like the hardware that runs in a back scene or whatever you want to call it, right? But when there's a need for the scalability of that or the scaling of that database is because we need to essentially handle the increased loads that we're getting, whether it's in terms of data volume, user request, the application complexity. And we want to do all these things without necessarily compromising the performance of that database. I want us to speak a little bit more to database scalability, right? How is it important for us to know the difference between like vertically scaling and also horizontally scaling? I think we had spoken to this a little bit in the first episode when it came to uh, 3 2 web apps, and we had spoken to about why it's important to know, hey, this is when I need to vertically scale, but also this is when I actually need to horizontally scale. Uh, I can give my whole spiel about it, and I think for me, it's important to highly highlight horizontally scaling a database. Right, this is when you are handling larger workloads and you're essentially adding more sort of resources to that workload, opposed to just increasing that single database instance. So you're just adding more CPU power, you're adding more memory, you're adding more storage. And essentially what you're doing there is you're just saying beef up that instance, right? You're just beefing up that instance and you're doing it in a straightforward manner where you're not really yeah, sure, it can help out a bit, but you're not necessarily doing a whole lot of justice if something was to, in this case, if you're to get more users, so you're to get more traffic that comes in. Can we speak to why data scalability is super important in a 3 2 web app?
I think we spoke about it somehow a little bit
Yeah,
because
somehow, but not too much. I think we want to expand on that, but
yeah, because when we talk about read replica, essentially what we are doing is horizontally scaling the database, right? And
exactly.
when and that not only increase your performance like we mentioned for the read operations, but that is a way of scaling, right, your database
Yep.
versus vertically. So when you decide on the database, you need your first, what you need to do is think about the size. You think about the CPU power, the size of the database, right, at the beginning. Now, if in case you need that, yes, you can always vertically scale. That is augmenting the size of the database. But most of the time, I would say for the sake of performance and yeah, for the sake of performance, adding more read replicas, right, allows you to easily scale your database and you know
I brought
No,
that up because I
yeah.
wanted to bring the conversation back up to read replicas. Just
No, that's a good one. It's a very tricky topic, to be honest. Like, it's not easy to discuss about it, especially when you're trying to choose what type of database you want to use, right? So, usually, if if you want to have like a no schema type of database, you would want to maybe use like a document database, right, or a key value database, and then it uses some technologies or a columnar database. So those
Yep.
types of database make it more easier to scale horizontally because they use some algorithms like hashing algorithms, especially when it comes to distributing the data within the nodes that are part of that database engine. So that's where you have to come in to think of how many users are using your application. Is it 100 users? Is it a million users? Or is it 100 million users, right? Is it a social media website? Is it a whatever application it is? You have to choose the right database for that. And it is it's not an easy discussion to have, but once you learn the different types of databases and their use cases, I think you can make a more um, solid choice on that. And like what my colleague Evans mentioned, and you, Joel, you want to have read replicas, you want to scale on that in that regards too.
Absolutely. Absolutely. Well, I know we've said a lot, and there's so much more to even talk about when it comes to the database layer, and we can keep going on and on and on and on and on. But we've only allocated usually 45 minutes to a a episode, and we're going to talk more about databases. Databases is a huge topic where we cannot necessarily fit everything into a 45 minutes, and now we're over episode. So there's more to come here, but I think I want to sort of close out this episode with some best practices. So, has individuals look to build a three-tier web app when it comes to the database? These are the things that you want to focus on, right? To summarize what we've talked about so far, we've discussed you leveraging multi-AZ deployments. So you want to always have a multi-AZ deployments in this case, a database example RDS. And the reason why I want to do this is for highly available or automatic failure. We also discussed optimization, optimizing your performance. So we discussed a lot of different approaches that you want to go. It could be utilizing read replicas, which we brought up quite a lot here. Optimize and utilize read replicas. And the reason why is you want to offload your heavy read workloads to a read replica to make sure that you're maintaining that high performance of that main database or that primary database. Additionally, we did discuss a lot of security practices or security measures. You always want to factor in security when it comes to whatever workload, and especially for databases. You don't want to not consider security for a database. So make sure you encrypt your databases, whether it's at rest, not even or. You want to do this at rest and in transit to protect your sensitive information. But also the key things like access controls, who gets to access what, but then most importantly, putting your database in the private subnet. You don't want this to be publicly available to whoever needs to have access to it. Then we also discuss backups and recovery. Take advantage of backups. You don't want to have your database be a concern when it's in trouble. You want to have backups in place that if it's in trouble, you won't know that it's taken care of, right? You can automatically fail over, or you can utilize those backups and also in this case, point in time recovery and restore that database in a specific point in time. Finally, the last thing I think we discussed is in general, how important database is in our 3-tier web app. It's an important piece when it comes to 3-tier web app. It's in my opinion, it's the crucial piece of a 3-tier web app. Obviously, you need to
It's the
store data.
soul. It's the soul.
It's the soul. Yeah, you need to store that data. You need to store that data somewhere, and it's database is where you store that data. You cannot necessarily store that data into the logic tier and just have the logic tier do all that thoughts or its thing. You want to store into the database. But yeah, with that being said, is there anything that I missed? I think again, this is very high level of what we've discussed with databases. There's so much more we can dive deep into. We can allocate and do some demos of how you can spin up databases, how you can do failovers. We're gonna plan that for the future in future sessions, and look forward to that. We will have that. But yeah, team, is there anything that I'm missing that I didn't bring up as we look to conclude this discussion?
I think you did a good conclusion there, and summarizing everything that we spoke about. Yeah.
Sweet. Awesome. With that being said, I always want to say, please, 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 please make sure to subscribe to our YouTube channel. Also, please do follow our LinkedIn page. And always, whenever we post, we ask of you to make sure that you like our post. It's kind of like me asking for you to kind of like our stuff. But yeah, please do that for us, please. With that being said, it's a pleasure. As always, every Friday, we look forward to sharing our thoughts on some of these services and these technologies. We're going to continue doing that. And we look forward to next week. We're going to announce what the topic is next week, hopefully by Monday. And we look forward to that conversation. Final thoughts, final words, team.
Just like and subscribe and show us what you want to learn more about.
Leave that feedback in our page and we'll make sure that we follow up on that.
Give us more feedback.
Awesome. Thank you all. Appreciate the time. And we look forward to next week's episode.
Have a great weekend, everyone.